Okay, class. I think that you will have a nice little break from some difficult stuff like function notation when we talk about slope. I think slope is something you know pretty much, and this is kind of just a recap of things that you've learned in the past. There are three definitions for slope, and it kind of just depends on the situation, which one you want to use. If you're looking at two points on a graph, then rise over run is probably what students think of the most. Rise over run. Rise is how much you go up or down. Run is how much you go left or right. Left or right as a run usually does not interfere with students' meaning of the word run. I can run left, I can run right. However, rise, going up and down, they kind of have a problem with that because they think, as a English word, rise is always up, and that's true, but as a mathematical word, we can rise in a negative direction, which is down. So if I wanted to go from this point, which is, say, point 1 with coordinates x sub 1 and y sub 1, to this point, which is point 2 with coordinates x sub 2 and y sub 2, I would go up and then over and form a right angle here. That's usually an easier thing to do than in this picture because usually you'll have grid lines and the lines will just follow right angles naturally. So our first definition of slope is rise divided by run. The next definition of slope is, well, a rise is y sub 2 minus y sub 1, and a run is x sub 2 minus x sub 1. So another definition is just replace the rise with y sub 2 minus y sub 1 and replace the run with x sub 2 minus x sub 1. And the final definition is just usually the definition that goes here, like a transitional definition, but I am starting to hear students talk about it more than I have in the recent past. The difference between two numbers is a change. Have you seen this before? Change in y over change in x. This is it looks like a triangle. Certainly you could say it is, but what it really is the Greek letter delta, which in math means a change in. Okay, so we're going to use the y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 definition of slope. And we're going to take these coordinates and we're going to plug them in and see what we get. Example 1, find the slope of the line that passes through 2, 1, and 7, 8. So if you think that this is point number 1 and this is point number 2, then your first y is 1 and your second y is 8. So y sub 2 would be 8, and then minus from the formula 1. And your change in x would be 7 minus 2. Evaluate the numerator, evaluate the denominator, and we're done. 7/5. Leave it as an improper fraction. Why? Because part of the definition, the numerator I see a rise, and the denominator I see a run. So it's kind of rare, but sometimes students will say, oh, that's 1 2/5. Well, sure it is, but I want to see it as 7/5 because then I get the concept of go up 7 over 5. Alright, we're going to try one more. Now this has some negatives in it, which does cause mistakes sometimes. And I also want to point out it doesn't matter which point you pick as first. Over here I could have picked this as the second point. I would have gotten the same thing. So just to show you that I can, let's say that that's the second point and this is the first one. My change in y is going to be y sub 2, 0, minus from the formula a negative 8. Minus a negative 8. That's not simplified to have those two negative signs one in after the other, so we have to remember that minus a negative is the same thing as plus a positive, or add. So it becomes 0 plus 8, or 8 in the numerator. So the denominator, you're changing x's. Well, let's see, that was my second x. So this is going to go -3, then minus from the formula, a 9. Now I have two negatives. I think of it as 3 plus 9, because they have the same sign, 9, 10, 11, 12. And then I have to remember, oh, it's a -12. A positive divided by a negative is a negative. So put that either off to the side or on top. My negative from there is going to go to the top. It's part of the simplified form. And then simplify 8/12. Let's see, 8 and 12 are both divisible by 4. So that would be 2 times and 3 times. So -2/3 is my slope for example 2. Now if you tried this yourself and you swap the order of those 2 points, you would see that you would get a -8 over a +12, which still simplifies to a -2/3. Okay, now for example 3 and 4, you try those, pause, come back, see how you did. Alright, I'm back, and these problems are almost completely done with very nice handwriting, don't you think? I did them a little bit differently, one from the other. Note that in example 3, I said this was my second point. The 10 and the 5 are leading off for my y and my x respectively. Now, I have not finished this one, but 10 minus a -12 is like 10 plus 12, it's 22. And likewise in the denominator, 5 minus a -6 is like 5 plus 6, or 11. So if I simplify that, that's just going to be 22 over 11 is 2 over 1, or better yet, 2. Do put it in a simplified form. The only time I want slope not as an improper fraction is when it is a integer. If it's 5 or -7, don't put it over 1. You don't need to. In this example, number 4, I said this was my second point, and 7 and 4 are leading off over here. And I did that because, see how I have all positives there and all negatives there? Maybe it's a little bit easier to go 7 minus a -5 and get a +12 than to go -5 minus 7. 12/5 is my final answer. It's as simplified as it's going to get. I do want to show you, just one time before I move on, that if I pick the points in the opposite order, I'm going to get the same thing. So if I go -5 minus 7, in the numerator, that's going to be -12. In the denominator, if I go -1 minus 4, I get -5. And instead of a positive divided by positive, I get a negative divided by a negative, but that's still just 12/5. Parallel lines, this is spelled P-A-R-A-L-L-E-L, and clever me, I've taken the 2 L's inside the word parallel and I've replaced them with the parallel line symbol. The parallel line has 2 L's, and that looks like a parallel line symbol. It's the equal sign turned on its side. And here this says L is parallel to M. Here's my 2 lines, L and M, and they look like they have the same slope. So that's essentially what it's going to be for parallel lines. So this is an example. I'm kind of making this up, but suppose this is the line y equals 3x plus 4. Maybe this is the line y equals 3x minus 2. And they both have the slope of 3. The y-intercepts, note, they don't really matter as far as determining whether something is parallel or not. So in general, you need to know that parallel lines have the same slope. Now, perpendicular lines. The symbol for perpendicular is, I don't know, not as, it's not taught as much perhaps in the primary grades, so I have to have students say, hey, what's that symbol? What's that upside down T? Perpendicular line symbol. It looks like 2 segments or 2 line segments, meaning at a right angle. Here's an example of 2 perpendicular lines. I drew this one, then I drew this one, and after having done so, it wasn't easy to visualize where the right angle was exactly. Like I started off like this, and there's a lot of lines that look like they're right, so to be sure, I got a little square here, and I decided if I can make that go right up against the square. That's probably good enough. That's a right angle. These lines are now perpendicular. Now, if I had equations to go with these lines, this might be something like y equals, let's say, 4x, slope of 4, and this would have a slope of something like y equals negative 1/4 x. The y-intercept doesn't matter as far as determining whether they're perpendicular, so maybe it's plus 0 in both cases, or maybe not. If it's plus 0 in both cases, then that would have to be the origin. So perpendicular lines, look at the slopes. One's negative and one's positive. That's opposites. One's negative, one's positive. Opposites. And the other thing that's going on you've seen recently, the number 1/4 compared to the number 4. 1/4 compared to 4. They are opposites and reciprocals. The 1/4 and the 4 is flipping the fraction. That's the reciprocal part. Opposites and reciprocals. Now, the way any book would do it, they would say the product of the two slopes. When you multiply them together, you get the same number all the time, and that number is going to be negative 1. A negative times a positive is negative, and a number times its reciprocal is 1. Okay, here's some examples. The question is, which are these lines perpendicular, parallel, or neither? Well, I read it out of order. Parallel, perpendicular, neither. It doesn't really matter. If you look at these, the slope is that number in front of the x, so 1/3 there, and it looks like 1 there, but that's not exactly true. When it's in the form y equals mx plus b, then it was solved for y, like 2 units ago when we were solving literal equations. So you need to take this and divide everything by 3. Now in that unit, if you didn't divide this by 3, you were just plain going to be wrong. Here, well, you made an error in your calculation, but if you're thinking, well, what's the slope here? Divided by 3, is that the same as 1/3? Well, yes it is. 1/3 x is like x divided by 3. So this bottom equation is really the equation y equals 1/3 x plus 1/3 in disguise. And they have the same slope, so the answer here is parallel. And over here, these are in standard form. Solve each of these for y. Take a second and do that, and come back and see what you get. Okay, color-coded. The one on top is going to be in blue, and I've done the first step as I've written it out the first line, which is, in this case, I subtracted 3x from both sides, so it comes over to the right, and it's negative. Divide everything by 2, and we get a slope of negative 3/2. The y-intercept is 4, but again, we don't care about that. The only time we would care is if we had two lines that had the same slope, and if they had the very same y-intercept as well, then they would be the same line, not necessarily parallel lines. Then this one in red, I subtract 2x from both sides. When I do, that minus 3y becomes negative 3y, and the 2x is negative, just like it was in the equation on the top, the blue one. Then we're going to divide both sides by negative 3. Everything gets divided by negative 3, so the sign is going to change here and become positive here and become negative there. So take a look at the slopes now, and I got negative 3/2 and positive 2/3. One's negative, one's positive, and they are reciprocals. So the answer here is these are perpendicular. Okay, a note about some special cases, which is going to come up in the next video and on plenty of the practice problems. Horizontal lines, they look like this. Well, not quite like that. Not as bad as that. This looks like it kind of goes up. And vertical lines, they look like this. And as far as the slope goes, this has a slope of 0. This has a slope that is, okay, I was about to put an equal sign, but let's just put a colon here, undefined. Undefined is not a number, so we should not be saying it equals anything. That's just a technicality. But I'll tell you what, if you say that thing has no slope, I'm not giving you credit for it, because I do not know if by no slope you mean 0 slope, or undefined slope. So stick with horizontal lines, m equals 0, m is undefined for vertical lines. You must also know that in horizontal lines, the form of the equation is y equals some number. In vertical lines, the form of the equation is x equals some number. You needed that for the last unit, so hopefully that's starting to sink in. Okay, we will see you in video 2 in just a minute.